Lesson 8.2 is on simplifying radicals. A square root is simplified if the radicand, so the expression underneath the radical, contains no perfect square factors other than 1. And this is true for any root that we're going to simplify. You want to make sure that there's no perfect square or perfect cube underneath that radical symbol. So for this first example, number 2, we got negative square root of 63. So we're going to break this apart because it can break down. It factors, 63 factors into, we'll have the negative square root of 9 times 7. And then using our product rule for radicals, we can actually break this apart even more and write this as negative and then square root of 9 times the square root of 7. And so our final answer for this, because we can actually evaluate what the square root of 9 is negative 3 square root of 7. Before I go any further, I should explain on here, I do have the product rule and the quotient rule wrote out. So I would make sure that you make note of that somewhere as you move through this lesson and the practice for this lesson. And then I also made note of the first 12 perfect squares because that's very helpful to know as you move through these questions that ask you to simplify. I also made a list of just the first 6 perfect cubes. They get very large very fast, so you don't usually need to know beyond that, first 6. And then I also wrote down 2 rules of exponents to keep in mind for this lesson. One is this product rule where you have x to the a times x to the b. You're going to add those powers. And then x to the a to the b, so the power rule, you're going to multiply those exponents together. So those are going to come into play in the examples that we see that involve variables. So make sure you keep those in mind. That was back in chapter 5 when we were first introduced to all those rules of exponents. So if you need to review any of that material, you would need to look back at chapter 5. So back to the first example now. So again, we broke it down into a perfect square, and then the square root of 7 we can't evaluate any further. And so this would be our final answer for this problem. Now for the next one, for number 4, this question says we want to simplify the square root of 169. This is actually a perfect square. So our answer, if we take the square root of 169, this is just going to be 13. And that would be our final answer. So that one is a pretty straightforward one. Number 6, our question's asking us to simplify negative 3 and then square root of 250. So first thing we do is we're not going to be doing anything with this negative 3 yet, but we can write this square root of 250 as the product of 25 times 10. And again, the reason I'm writing it that way is because 25 is a perfect square, and I'm going to be able to take the square root of that number. So again, you're trying to get rid of all the perfect square factors. So now we have negative 3, and again, we can break this apart into square root of 25 times the square root of 10 using our product rule for radicals. And this is now going to be negative 3 times 5 times the square root of 10, which is equal to negative 15 square root of 10. And then that would be our final answer. Our next example is number 8 out of the book, and it says negative 6 square root of 144. So this here, the square root of 144, that's 144 is actually a perfect square because 12 squared is 144. So this just turns into negative 6 times 12, which equals negative 72. And that would be my final answer for that one. The next set of questions ask us to simplify using the quotient rule. So number 10 out of the book says negative, and it's the square root of this rational number, 30 over 49. So using the quotient rule, we can break this down so that we have the negative still out front, and then we're going to have the square root of 30 over the square root of 49. 30 we can't break down into any perfect square, so that's actually just going to stay the square root of 30 on the top. And then on the bottom, the denominator of this rational expression is going to end up just being 7 since the square root of 49 is 7. So our final answer would be negative the square root of 30 over 7. For number 12, we're going to use, again, the quotient rule. So we're going to break this radical apart so that we have the negative still out front. We'll have square root of 45 on the top and the square root of 144 on the bottom. And what's nice about this question is the denominator ends up being a perfect square. So the square root of 144 is 12. And then the square root of 45, we can actually rewrite this as the square root of 9 times the square root of 5. And the square root of 9 is 3, so we have 3 square root of 5 over 12. And then we do need to simplify this further. 3/12 is the same as 1/4. So we really don't even need to write the 1 out front. So we would just have the square root of 5 over 4. And that would be the final answer for that one. Now, the next set of questions have us just simplifying using a variety of rules, and we're going to be introduced to more variables in these questions, and that's where those rules of exponents are going to be really helpful for these problems. So for this first one, we have the square root of 25 y to the third power, so the square root of all of that. So we're going to start off by using that product rule for our radicals and write this as the square root of 25 times the square root of y to the third power. So we're going to break those two apart. Now the square root of 25 ends up just being 5. So we can go ahead and evaluate that. And then the square root of y to the third power. Y to the third power, keep in mind, that is the same as y squared times y to the first power. So when we write this radical, we're going to rewrite it as the square root of y squared times the square root of y to the first power, which you don't need to write that 1. And the reason we're writing it that way is because we can actually take the square root of y squared. So this is now going to be 5y times the square root of y, since we can't go any further with that piece. For the next question, number 16, we have the square root of this expression 54x to the 7th. So 54, we'll write this as square root of 54 times the square root of x to the 7th, which, again, that square root of 54, we can write that as the square root of 9 times the square root of 6. And again, the reason we're writing it that way is because the 9 is a perfect square that we can actually take the square root of. And then this x to the 7th, we can't write it as something squared because nothing times, no whole number times 2, because there's going to be some examples where we can actually write it as, for example, if this was x to the 6th, we could write that as x to the 3rd squared. And then when you take the square root of it, you'd be left with just the x to the 3rd. But we can't do that trick with this one because it's an odd number. And so we have to think about it as we did with this previous question where we broke it down into y squared times something times something. In this case, x to the 7th, you would get from doing if you had x squared times x squared times x squared times x to the 1st. So we're going to rewrite this as times x squared. And there are other ways you could think about this, because you could think of it as, like I had said, x to the 6. You could think of it as x to the 6, break that down. So kind of like with a lot of the math problems we've done in this class, there are different ways to think about these questions. So don't think that the way that I'm going through this is the only way to go about simplifying. It's just one of, a few different options. So that's what x to the 7th would break down to, because x squared times x squared times x squared times x, you would add all those exponents together to get to 7. So now we go through and take the square root of what we can. So the square root of 9, that is 3. Square root of 6 we can't do anything more with. X squared would just be x. This x squared would just be x. This would be x. And then the square root of x is still there. Now simplifying this further, we'd have 3. And then these x's here would be x to the 3rd power. And then these two here, the square root of 6 times the square root of x, are basically going to be using that product rule that helped us break it apart to put these two together. So this would be the square root of 6x. And then that would be my final answer for this one. For our next problem, we're going to take a look at question number 18. So question 18 says we have the square root of 40m over n to the 6th. So this one, using that quotient rule that we talked about in those previous examples, like on number 10 and 12, we're going to break this down into the square root of 40m over the square root of n to the 6th. So now we're basically going to simplify the top and we're going to simplify the bottom. So the top we can rewrite as the square root of 4 times the square root of 10 times the square root of m, because again the square root of 40 breaks apart into the square root of 4 and 10. And again we're picking those values, those factors, because 4 is a perfect square. And then on the bottom, this is that trick that I was talking about where we can think of this now, since this is an even number, we can think of this as n to the 3rd squared, because now when we take the square root of that, you'll be left with just this n to the 3rd power, because the squared and the square root will basically, you could think of it as canceling out. So now, and actually going back to this here, again, n to the 6th you could think of as n squared times n squared times n squared. And then taking the square root of each of those, you'd have n times n times n, which would be the same thing as n to the 3rd power. So either way, it's going to be the same answer. If you think about it using that product rule, or if you use the power rule for exponents. In this case, I'm using that power rule. So square root of 4 is 2. And then I actually can't do anything with the square root of 10 or the square root of m, so I'm going to combine those to be 10m underneath the same radical. And then on the bottom of our rational expression here, we're just going to be left with this n to the 3rd. And that would be the final answer for that question.